There's two functions. There's h of x, which is the line y equals x, and then there's the k of x function, which is y equals x cubed. H of x is the straight line, so the red one's the straight line, and the blue one is the curve. All agreed? So what we're going to do next is we're going to try and find out the points of intersection. Well, we want to find out this blue one here. We know 0, 0 seems to be one of them. There seems to be 3 points of intersection. Would you agree with that? A green, a red, and a blue. Now, when they intersect each other, the two y values are the same. This implies that x cubed is the same as x. You understand where I got that? The two formulas. X cubed equals x. Bring them over one side. X cubed minus x equals. Okay. Factorize out. X minus x squared minus 1. Okay. Now we've got our first answer. What page is this on, by the way? Feel free to fill it in now, like it's your pal. Idea. Now, x equals 0. Would you agree with that? And what's the other one? X squared minus 1 equals 0. You can do a difference of two squares, can't you? And what are the three answers in question then? X equals minus 1 and x equals 1. Now, it says points of intersection. I've only found the x values. I haven't found the. Now, remember, you can choose either graph you want. You can either choose y equals x cubed or quite simply y equals. I'm going to choose y equals x. Yeah, so this means this one here is going to be minus 1 minus 1. This one here is 0, 0, and the one up top is 1, 1. Any questions thus far? Now, next thing. We've done that. Now we're on to part B. Find the total area enclosed between the graphs of the two functions. Total area enclosed. Oof. Well, that's difficult because what you reckon? I think the total area enclosed would be this yellow region here and this green region. Now, what I might say is they're symmetrical, aren't they? If you calculate the green one and double it, you have it. Now, we've just checked the marking scheme. The green area is in fact the same as the yellow area as we thought. So all we need to do is find the area of the green area and double the answer. Ready? So let's do this. I'm going to do answer part B on this page just because all my information's here, isn't it? Okay. Now the first thing I'm going to do is going to try and find out the area of the, for argument's sake, let's call it the area of, see this triangle I'm drawing? And see the way I'm shading it in blue? That's a triangle, isn't it? Now you have a choice. You can just do a half base times height, can't you? What's a half 1 times 1? Half 1 times 1? Just a half, isn't it? Now, most of us probably wouldn't think that way, would we? Most of us would integrate from 0 to 1. What's the formula of the function? X dx. We would have done that, wouldn't we? More than likely. You'll get the same answer, believe it or not. Now, see that blue triangle? That's too large, isn't it? And what do we have to take away from it? This little yellow, oh sorry, I already used yellow. This little pink section here. Did everybody see that pink section? Now, what integral would that be? Minus 1, 0 and x cubed dx. Is that okay? You could take the shortcut. The shortcut's on. What's the shortcut again? When the limits are the same, you could just do this in one go, couldn't you? See the way the limits are the same? That would be on. I don't like doing it personally, but it's on if you want to do it. But I'm going to integrate this now. Ready? Okay. Slightly longer, but I do believe it to be the safer method too. Is everybody happy with x squared over 2? From 1 to? And then when you sub in 1 squared over 2, which is Just a half, isn't it? And that's what we're expecting, wasn't it? We're expecting a half. And we already knew that from the triangle earlier on. Now what about this part here? X4 over from, and then same deal, isn't it? It's going to be a quarter, isn't it? Because the 0 would be 1 to the power of 4 minus 0 to the power of 4 over 4, just a quarter. And a half take away a quarter. And your answer is 0.25, and you're done. And we have to multiply by 2 because I only got the green area. I didn't get the yellow area. So multiply that by 2 and we get 0.5. Okay, Jen. Okay, can anybody tell me what kx is? What's kx? X cubed. Does everybody remember that? Yeah. Does everybody remember how to get the inverse function again? You say y equals x cubed, and you interchange the x on the, and then you interchange them, and you then say x equals y cubed, yeah? And then you get y on its own. How'd you get y on its own? The cube root of x, or what's another way of writing that? X to the power of third. So k inverse x would be x power third. Y equals cube root of x. Now there is another way of doing it. I'll show you the other way of doing it now. Just going to rub all this out. You happy enough with that? So the deal is that a function and its inverse are always reflected in the line y equals x. So what's going to happen here is, do you see this line y equals x? I think it's already drawn here. Does everybody see this line here? See that green line? That's the line y equals x. It makes a 45-degree angle. Yes? Now, here's what we're dealing with, right? I'm just going to show you now. Does everybody remember that this is the point 1, 1? And does everybody remember that this is the point -1, -1? Yeah? So would everybody agree that is it 5 blocks, is it? So each block is worth 0.2. Would you agree with that? 0.2, 0.4, 0.6, 0.8, and 1. I have an idea. I'm just going to put in this here. Looking, I'm going to go table function. Table function. I'm going to do x to the power of a third, or I can use the cube root of x, can't I? My choice. Now, I have an idea. I'm going to start at -1. Why am I starting at -1? Yeah, that's right. That's where this graph starts. I'm going to end that. I might do a step of 0.2. Does that make sense? Now look at this. Ready? If somebody has this in the calculator, it'll speed me along nicely. So -0.8 is the same as what? 0.928, so around here. Okay, what's the next one? 0.85, so about, what's 0.6 again? So that's 0.6, isn't it? And that's 0.6, 0.6, that's 0.8, and that's 0.85, around there, yeah? Does anybody see what's happening yet? It's a mirror image around the, so what's it? 0.4 is 0.75. So 0.4 here, and that's 0.6, about 0.75 here. And then next one, 0.2 and 0.5, yeah? So 0.2, 0.4, 0.5-ish. Close to 0.6 though, right? So around there. And then 0 and 0. Does everybody see what's happened there? I'm drawing a mirror image of it's almost like a leaf. See the way I'm finishing it off? What do you think is going to happen on the upper end? The same, except it's reversed. And that is your, sorry, I messed it up there, but because I have my table function, I can make a pretty good go of it, can't I? But you don't have to be spending too long on it either. I honestly don't know. I'll show you the marking scheme now. You ready?